Collapsology. What is collapsology? You may know this word, but may not know its signification. Collapsology is the science that studies systems collapse and tries to understand and anticipate them. More particularly, collapsology focuses on the risks of a collapse of the industrial civilization and what might replace today's society. So here we will define the system Earth and ponder over its collapse within the few decades to come. So here we'll define the system Earth. Well, not this one, obviously. Not this one, no. But this one, yes, and ponder over its collapse. So, of course, by saying Earth, I'm more precisely speaking about the extinction of biodiversity as we entered in the sixth mass extinction of history, which is even faster than dinosaurs' extinction. I'm also speaking about the entire collapse of our economic system and also about our agricultural system, and then about us as a species. On this graph, we can see that since the beginning of the industrial age, all the commodities per capita, food, services, and industrial output per capita have continually increased. As a result, global pollution increased and the remaining non-renewable resources started to fall down. A group of scientists created a model to predict these trends. The prediction turned out quite accurate for the 3 decades from 1970 to 2000. Then they predict a threshold in 2030 from which the global population would start to decrease as a result of the natural resources and ecosystems collapse. I first heard about collapsology in 2018 when I attended a conference held by Pablo Servin. He's a biologist and a scientific researcher. He has made lots of conferences and he's the one who democratized the concept of collapsology in France thanks to his books such as Comment tout peut s'effondrer. During his speech, he referred to a study entitled Trajectories of the Earth System in the Anthropocene. This study highlights the link between climate change and self-reinforcing feedbacks that accelerate the global warming and tries to determine a threshold that, if crossed, would lead our planet to a hothouse Earth. Watching lectures, talks, or YouTube videos is great, but I wanted to read hard understanding scientific content. So after hours, days of working, studying, reading this very long study of 8 pages, I came to one conclusion on our environmental state. We are in deep shit. I will speak about what I would have loved to see in a YouTube video, the 15 self-reinforcing feedbacks that will lead us to our death. Well, more seriously, to entirely grasp the issue, the study takes into account that the different societies around the world have contributed differently and unequally to pressures on the Earth system. And thus, in the future, they will also have unequal capabilities to alter future trajectories. That's why we need to consider the total of human impacts in order to analyze the future trajectories of Earth. So, in this presentation, I will raise few issues. First one, is there a planetary threshold that, if crossed, could prevent stabilization of intermediate temperature rises? Then, understanding the geophysical and biosphere feedbacks intrinsic to the Earth system, where the threshold might be. And finally, how human actions could create a new pathway in order to steer the Earth system away from the threshold and towards the maintenance of interglacial-like conditions. So the scientists of this study made this graph considering the climate since we entered in the Anthropocene and showing the climate evolution through time and different more or less stabilized states. So the horizontal axis represents temperature, the axis in depth represents time, the past is in the background, the future is in the foreground, and the present time is represented by the Earth in the middle. The vertical axis represents the stability, so they considered the potential energy of the system. So this energy is the same energy that makes you go down from the top of a hill. We can see a stabilized state at the bottom of a basin and an unstabilized state at the top of a hill. The Paris Accord target of 1.5 to 2 degrees of warming could already be enough to push the Earth system irreversibly onto a hothouse pathway. And then there could be a stabilized basin of attraction, but this would require a fundamental change in the role of humans on the planet. So now let's give an insight into the biogeophysical feedbacks. So these are natural phenomena that increase the temperature. They can be seen as tipping waterfall or dominoes. Then these feedbacks can either be positive, so they accelerate a perturbation, here global warming, temperature, or they are negative, so they slow down a perturbation, such as carbon uptake by the ocean and land, but these are weakening, so thereby the global warming is accelerating. So on this map we can see the 15 self-reinforcing feedbacks. That tells us that each feedback has its own threshold, its own tipping point where the feedback process becomes self-perpetuating. They also tells us that they are likely to be reached within the century. So now I'll explain some of the self-reinforcing feedbacks. So one of the most known feedbacks is ice sheets and glaciers. So because the atmosphere temperature is increasing, ice is melting, which leads to the decrease of the surface albedo. Albedo is the total of white area on Earth that reflects the sunlight. And because this area is decreasing, absorption of solar radiation is increasing, and this leads to the increase of atmosphere temperature. Another one is thermohaline circulation. The natural water currents are powered by the meeting of warm and cold water at the poles. For example, in the Atlantic Ocean, you can see a current of warm water going towards the North Pole. This warm water travels at the top of the ocean because warm water is lighter than cold water. When this warm water is cooled by the pole, it goes down the ocean, and this natural movement accelerates the natural currents. Indeed, because ice sheet is melting, the cooling is less efficient, the current slows down, and this is a real danger for self-regulation of temperature and also for climate patterns. This could lead to serious disturbances. Another example is permafrost. Permafrost is frozen earth that naturally captured methane from the decomposition of organisms in the past. So because of the warming atmosphere, the permafrost is thawing. Then it releases its methane in the atmosphere, and methane is one of the worst greenhouse gas, so the atmosphere is warming as a result. As I told you, there are 15 loops like that. If you want more information, you can go at the end of the video and find 4 more slides that describes other very important self-reinforcing feedbacks, which are water vapor, coral reefs, phytoplankton, and rainforests. To summarize, by considering the total impact of these feedbacks, one may wonder how many more degrees will we get by the end of the 21st century. At the end of the study, we can find this table which summarizes the total impact of the feedbacks. Therefore, for an approximated 2 degrees of warming, the climate would in fact be warmed by 2.5 degrees because of this natural phenomenon. It might seem a little to you, but let me remind you that we don't know where the threshold is. This warming of 2.5 degrees would be enough for the feedbacks to be self-perpetuated and thus to push the climate at skyrocketing values. For the next decades to come, the scientists are advising us to face the political, economic, social, and environmental changes. We'll have to grow resilient societies. We are living the warmer period human beings ever experienced. Therefore, we need to act together to reach this stabilized state. We'll need to develop insurance, buffers, redundancy, diversity, management of feedbacks and typing cascades, polycentric governance systems, and to think Earth system as a whole. To put it in a nutshell, many solutions exist, but the most important one remains: what planetary stewardship strategies are required to maintain the Earth system in a manageable, stabilized state?